Alrighty. What's up, everyone? This mic's working. Yeah. Okay. Cool. We're on day 41. Yeah, man. Day 41. It's going all right. I've been a little bit busy this past week, which hopefully this week can simmer down. Have a lot more free time this week. So stay tuned. Hour-long videos this week. This whole week has been very slow since 5 days ago. 1, 2, 3, 4, 5. Like 5 days. This is gonna be 6. So this past week's been shit. So if I'm being real, it's been 20 minutes, 7 minutes, 20 minutes. It's not even like 2 hours here on YouTube. But I appreciate everybody for subscribing to the channel. 143 is a lot. I started off with like fucking 5 or 6, so this is crazy. Yeah, today won't be a long video as well. It's a Sunday. I just had a long day with family and stuff, so goal is to I don't even know, man. I'm gonna just do what I can do. It's hot as hell in here. So post-order traversal, I think we were learning this yesterday, but we stopped because my dad yes, we're learning what? Oh, we did pre-order yesterday. Nice. So we did yeah, that's what I was looking at. I was like, bro, what? I thought we did this shit. So 42176, so it goes to the left and then to right. Yeah, so and then we add it into the visited list. Sorry. Now the next one, 1, 2, 6, 7, 4. So post order. So we gotta understand pre-order traversal and post order. Post order traversal also visits all nodes in a tree. Visit all nodes in a tree. It's called post order because because the current node is visited after the children in the following tree. Let's just okay, now let's do this one. Oh man, so unlike pre-order where we visit the current node first, post-order means traverse left subtree, traverse the right subtree, then visit the current node. So it's 4, 2. So then we start from 1, 2, and then we'll do 6, 7, then 4. So okay. So recursively traverse the left subtree. So step 1 right here says recursively. Okay, so we have to like get the. So obviously it goes into visited. So what we did here is we have to get to 1. So we have to do the children first. Damn, this one's a little bit confusing. Recursively, so let's do what we did before. Focus on step 1 first. Yeah, so it's exactly like step 2 from pre-order. You're still asking the left child if it exists to do a post-order traversal. So the way it works is if self.left is not none, then we have to recursively do it. So remember, but this does the 2, 1. How do we? My bad if you can hear my sister in the background. She's just always yelling. Right. You're still asking the left. You're right. You're going to code method. Just do the left subtree traversal correctly. If you want, you can share it. Okay, so I know that wait, what the fuck? I know that there, boom. If self.left is not none, right? Boom. Okay, so now we have to traverse the subtree zone. Thing is, we're going upwards. How do we get the last one? Alright, so let's try it on my own and then move on. This is the problem with me learning. I always when I'm stuck, I go right into like trying to get help for the solution, and that messes me up. So yeah, I gotta. Shit, dude, I don't know how to get the one. Let's just try self dot left. We have to recursively. Oh, like how do I do the reverse? I don't know what, bro. This doesn't work. What the fuck? So this does 2-1? There has to be some backed like. Bro, traverse. Dude, I'm not understanding this traverse shit, bro. I thought it was something else, I guess. If self dot, what are we doing, the right side? Right is not none. Self not okay. Visit the value of the current node by pinning its value. Is it steps like? Is that what like is doing? Like, hold on. If I go enter, so this right here is an issue. Visit the value of the current node by appending its value to visited array. So append the visited value. Dude, my sister needs to shut the fuck up, bro. Alright, so just how we did it. Visited dot append self dot the value, and then we return visited. That one's called pre-order, right? Yeah, pre-order. I gotta understand this. I gotta understand. Dude. She needs to shut the fuck up. Your voice order code. So that's not none. Yeah, okay, that's my code. How it works is so left 2, right 3, current. Post order means left. There's 2. Right. Say it's your 4, 2, 1. Calling root post order this. Start at 4. First go left 2. At 2 go left 1. So there's no left right children. Add 1. Visit 1. Return. Go back to 2. But go back at 2. And then add 2. Turn to 4. Back at 4. Go right. Oh, so then boom. Go right. Is the solution the same? Yeah, exactly the same, bar for bar. Alright, so back at 4, go right, 7. At 7, no left child, go right, 6. At 6, add 6, so 1, 2, 6. Back at 7, add 7. 6, 7. Back at 4, add 4. Final result. Difference from pre-order. Pre-order is node left, right. So in pre-order, you visit the current node. So it's left, right node. So in post order, you visit both children first. Then you visit the current node last. Why this matters. Each traversal order has different use cases. Pre-order good for copying or receiving the structure of a tree. Post order useful when deleting or freeing tree memory. Bottom up. In order. Okay, I think it's the next one's in order now. Yeah, exactly. So 1, 2, 4, 6, 7. So it's going up. In order is the most intuitive way to visit all nodes in a tree, and it's called in order because the current node is visited between its children. As results in an ordered list and nodes the following tree. So 1, 2, 4. So yeah, we gotta recursively go left first. So if self dot left. I see. It's this. Everything's the same. In order, post order. It just depends on the steps. Okay, I got it. So if self dot left is not none, we're gonna recursively call so self dot left dot in order the visited, right? Honestly, I'm tired of doing this, bro. Just copy this. Oh shit, I don't know. Dude. If self right, then we do the right. Okay, this is wrong by the way, because this step is wrong. This is step 3. I just caught that. Now we get the array that we're in, so we get the visited dot append we want to append the current value, so we do self dot val. Then at the end we return visited. Boom. Let's go, boys. Let's go, W's. Okay, on lockdown it's common for one user to navigate through the nodes. We even creepily gave the stalked user a notification that someone has looked at their profile. To make this feature work, complete the system. It should take a value as input and return true if the value exists in the tree, and false if it doesn't. It's a recursive method, as you probably guess. So if gotta check if that value is the top node, then it's not, then it is. Boom, then we return. So then we return true if it's in it. So recursively call it. What's the next one? So we gotta recursively find like so what is the goal? You're given a value like value 6 and you need to check, is there a node in the tree which will, if yes, return true, if no. Okay. Why does it do that? Wait, is none. Like it points to none. Bro, is this shit broken, bro? Oh my god. For me, bro. Oh, so soft. So I didn't even need a curve. Fuck. So we recurse what we call it. Here it checks what it does. Ah, yeah, makes sense. Ew. Fucking ill. Alright, we'll save this one for tomorrow. Let me understand this. self dot value. That means the current node's value. So line 2, yeah. So if the self dot value equals the value return true, current node we're looking for, just return true immediately, right? If value less than, if the value we're looking for is less than the current node's value, the AC tells us that this is the left of the subtree. Now, if self dot left return, so if self dot left is not none, or cursorily call exist value on the left child. If there's no left child, return false. If there's no left child, return false. The value isn't in the tree. If self greater is just the same shit. Is that 1 at 10? Is 10 equals 12? No. Is 12? No. So it's 12 greater than, yeah, so go right. 15. At 15? No. 12 less than 15? Yes. Go left. Damn. Makes sense. That's why we're recursively calling it. Makes sense. Oh, damn, I wish I solved that. I wish I solved that. Alright guys, I'll try to get better. My fault guys. This week's been shit. But, yeah, longer video tomorrow. I'm sorry for the background noise, my sister, and, yeah, we did much more than I thought I was gonna do, so, yeah. Alright guys, see you guys later. See you guys tomorrow.